Modeling, tuning, and closed loop control of soft process. It means simulation experiment that you have to do in the MATLAB. Here, if the order of the process increases, you will get more dead time. If I draw the response of first order process, first step response to a first order process. If you draw the step response, step input, if you give, the response will be looking like this. Am I correct or not? First order response. Second order, what is the difference between first order and second order? Here, you can notice that here the angle is 90 degree. For second order, it is not 90 degree. That is the difference. Otherwise, both are looking same. As order increases, suppose order is fourth order means it will be like this. That's why in the level process, you got S curve. This is called S curve, reaction. As order increases, you will get S curve. The dead time will come into picture. Initially, there is no response for some time as order increases. To understand how the delay comes in, you can understand from practical example means, let us assume that each vehicle, car or bike is first order, let us assume. Minimum order is first order. No zero order in the world. Zero order means analytical equation. No system in the world is zero order. Zero order means immediate output. It's not possible. It's not possible. If you get something means for that you can react after some time only. Millisecond or microsecond delay definitely minimum required. All vehicles are first order. Let us assume. If you are in the signal, some 4 or 5 vehicles are there before you, the signal changes, all vehicles simultaneously moves. No, you have to wait for some time. So as order increases, there will be delay in the response. Suppose fourth vehicle means for that vehicle in that system, it is fourth order because some three first order systems are cascaded to that, added to that. That's why it is fourth order system. First vehicle only first order, second vehicle second order, fourth vehicle fourth order. So there will be a delay that you can understand. That's why you will get a delay here, TD you will get. The time constant is from here to here, that is called 63%, 63.2% is the time constant, TP. Again, you know how to calculate. That's why to get reaction curve, we are going to simulate a fourth order process. Fourth order process, let us take this way, 1 by s plus 1 to the power 4. 1 by s plus 1 to the power 4. That you have to simulate in the MATLAB. So if you expand this, what you will get? S power 4 plus 4 s square plus s cube plus 6s square plus 4s plus 1. So how to get this? 1, 1, 1, 1, 2, 1. This is zero order, first order, second order. Third order means 1, 3, 3, 1. Coefficients of the terms. Fourth order means 1, 4, 6, 4, 1. You have to use this triangle to find the coefficients. So fourth order means this is the coefficients. Coefficients are 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. This is fourth order transfer function. Therefore, the fourth order transfer function is 1 upon this. This is for this we have to do closed loop control. We have to do closed loop control. So to do closed loop control, we have to find Kc Ti. Here, since it is simulation, it is fast only. Whether it is fourth order, 10th order, 100th order, same time it will take. Simulation only. Mathematically, we are calculating. Computer calculates mathematically output. That's why all are fast. That's why we can tune both ways, reaction curve method as well as closed loop method, sustained oscillation method. So we have to find in both methods KC and TI, we have to compare the result. That's all. KC and TI, we have to calculate. First thing what we have to do, first thing is, we have to take the fourth order process. 1 by s plus 1 to the power 4. Reaction curve method means give you a step input. You will get the reaction curve. You will get the reaction curve. Find case KP, find KP, TP, TD. Dead time you have to find. This is dead time. Time constant you have to find. TP. Then gain you have to find. KP. If you know all these three values, you can find the tuning parameters. That is KC equal to 0.45 for P only controller. For P only controller, then PI controller, PID controller. All three controllers you do so that you can, what is the response you can see. For P only controller means only in KC. For PI controller, you have to find KC and TI. For PID controller, you have to find KC, TI, TD. For P only controller, KC equal to TP divided by TD multiplied by KP. So we have to find that way. TP divided by TD multiplied by KP. No TI, no TD, because only P only controller. PI controller means 0.9 times TP divided by TD KP. PI controller means 0.45 and 0.9%. For TI, 3.33 times TD. For PID controller, this is how much? 1.2 times. 1.2 times TP divided by TD KP. This is equal to 2 times TD. This is 0.5 times TD. That's all. So we have to find the reaction curve, find TD, TP, KP, and substitute, you will get the tuning parameters. By simulation, you have to find the servo and regulatory response using P only controller. Find servo and regulatory response by using PI controller. Find servo and regulatory response using PID controller. You will get 6 responses you will get. Then tune by using closed loop method. So for that, what you have to do? You have to take the process 1 by s plus 1 to the power 4. Put a P only controller. Put it in closed loop. Vary KC. It exhibits sustained oscillation. That find K max. You find TU. You got these two parameters so that you can find for tuning parameters. You can find tuning parameters, that is P plus I, P plus I plus D. KC, TI, TD, you have to find. This is 0.5 times K max. No TI, no TD. This is 0.45 times K max. TI equal to TU divided by 1.2. No TD, only PI controller. Here 0.6 times K max. So you get all the 3 controller parameters, you can do the simulation. That's all. Now we'll see how to do all these experiments by using MATLAB. Here also you have to get another 6 experiments. For P only controller, find servo and regulatory. For PI controller, find servo and regulatory. Compare these two parameters. How to compare these two? How to how to check which controller is best, how to find which controller is best. For that, what we have to do? We have to do one measure. That measure is called ISE-IA. You have studied integral square error, integral absolute error. These are all parameters to measure the performance of controller. So here, if you draw the graph for error, suppose it is looking for regulated response, it is looking like this for one controller. Another controller, it is looking like this. Which is best? First one is best. If you integrate this by taking absolute error, means positive also becomes negative, also becomes positive. If you integrate that, you will get one area under this graph, you will get absolute error if you integrate. Similarly, for this also, you will get under area under this. Which area will be higher? Second graph. Therefore, ISE-IA must be minimum for better controller. So you can analytically, you can find which one is best controller, you can find. In this way, you have to find ISE-IA. How to find all these things by simulation, that we'll see now. Simulink. Simulink is the blocks are available. Suppose you want a transfer function, means that is available as a block. You want a PID controller, means you need not write program. That is, that program is put in a box and it is available as a component. You can just connect. It will be converted into program automatically inside. So that is called the Simulink. The Simulink will be very simple to do simulation. That's why we have to invoke that Simulink. So I got Simulink. So you have to get a blank model, create a model. So you'll get a blank model. So you got a blank model. If you browse that library, you will get these blocks. You have to drag and drop, that's all these modules. You need a transfer function. You need a transfer function. For that, you will get sources if you go. Continuous if you go, you will get transfer function. Here, you are having, where is the transfer function is available here. You can drag and drop, that's all. So you got transfer function. Initially, what you have to do? You have to do, you have to do reaction curve. For that, we need a step response. That's why source, if you go, you will get step input. You need step function is required. So you got step function. So you need sinks you required. So scope, to see the response, you need scope. So you need a scope, that's all. To get reaction curve, you need a transfer function, step function, and scope. Scope is to see the response, that's all. So you have to connect this and this. You have to connect this and this, that's all. So you have to enter the correct parameters. Here, the transfer function, if you see that, here it is a first order transfer function. Time constant is 1. Numerator is polynomial is 1. It means k equal to 1. Denominator 1 means s plus 1. S plus 1. But we have to enter fourth order. So what we have to enter is 1 s power 4, then 4s cube, 6 s square, then 4s, then 1. Now we entered fourth order. That's all. So it becomes fourth order. Yes, we got that fourth order. Fourth order response we got. So here, step input, we have to give correct parameters. It is not correct. Here, the step time is 1, but you need at 0 time. You need a step input. Final value is 1. Unity step input you are giving. That's why it is okay. So scope is you have to see the response. That's all. Now we have to simulate. Let us simulate for 10 seconds. If you simulate, it won't give complete, it won't settle in 1 second. Let us check. Yes. It is not yet settled. The response we got, step response we got, but it is not yet settled. That's why we have to simulate at least for some 20 seconds. 20 seconds. We got the response. Reaction curve we got. You find dead time. You draw a slope where the slope is maximum. It will cut the x-axis at this point. Find the time at which it cut the x-axis. So you will get the dead time. Time taken to find reach 63.2%. You draw a vertical line at 63.2%. You will get time constant. Gain is unity. Where it is settled? Settled at 1. What is the input you gave? 1. So the output is 1. Input also 1. That's why gain is unity. Therefore, Kc equal to 1. So we got Kc equal to 1. Let us go here. We got, I know the values. That's why I'll find the tuning parameters by reaction curve method. Kc equal to what? For P only controller. Kc equal to what? Tp plus Td equal to total time taken to reach 63.2% is 4.35. Here, dead time is 1.35. Td equal to 1.35. From the graph you can get. Therefore, Tp equal to 3 seconds. Kp equal to what? Kp equal to 1. So now we can find the tuning parameters. What is that? Kc equal to what? Find Tp equal to 3 divided by 1.35 multiplied by 1. How much? This is for P only controller. 2.22. Okay. For PI controller, Kc equal to 0.9 times 2.22. How much? How much? 1 point. How much? 2. Exactly 2. Okay. 2. Okay. Kc equal to 2. Ta equal to what? Ta equal to 3.33 times 1.35. Equal to how much? 4.49. Okay. For PID controller, tuning parameters are Kc equal to 1.2 times 2.22. How much? 2.66. Okay. Ta equal to 2 times 1 point, dead time is 1.35. Therefore, 2.7. Ta equal to 2.7. Td equal to what? Td equal to 0.675. 675. Am I correct? Check. Check. Correct? How much? 1.35 divided by 2. 1.35 divided by 2. 0.675. Okay. We got the tuning parameters. Now we can simulate. So we have to simulate this and we'll go there. I got all this PID. In continuous only PID is available. This transfer function also available in continuous. Step is available in the source. This is available in mass. Sum, this block is called sum. This is available in the sync. These two are available in the math. So you can search by name and you can get the blocks. Now we got all blocks. Now we have to give step input. So we have to get the step input also. This is sources. Step input is required. Yes, we got step. This is display. These two are display. To display IAC, IAE, I got these two. So PID block we got. So connect this, connect this, connect this. So we have to calculate error. Error, if you know, you can calculate two things. One is ISE, IAE. I will tell what is that. Then I will come here. Okay, after finish, I will tell that. We have to find ISE, IAE. This is to get ISE. Square of that error you will get. And here you will get absolute error. IAE. So we are taking error and give it to square module. So you will get integral of square of that error you will get. Here integral of absolute error you will get. So everything is given. Now we have to check the parameters of step input. So it should be given at 0. So we are giving 0. That's all. Unit step input. And the PID controller for P only controller. What is the value we got for P only controller? What value you got? 2.2. Am I correct? 2.22. 2.22. And here you have to see the formula. PID. Everything is in the numerator. That's why I we can substitute 0. Sometimes if it is Kc by Ti means you should not enter Ti equal to 0. So here we can enter 0 because it is I only. D also we can enter 0. That's all. So we entered P only controller. Now we can simulate for servo response. If you give step input, here in simulation, 0 is the nominal value. 0 is the nominal value. Wherever it is settled, that is nominal value. If 50% already it is settled at 50% means 50% will be taken as 0. You understand this? So like that you have to do simulation. So run for some 50 seconds. Run for 50 seconds. Here I didn't enter the correct parameters. We have to do negative feedback. I gave positive feedback. That's why unstable. So we have to give minus sign. I forgot to give negative. Now it is negative feedback. So now we have to simulate. We got ISE, IAE. This is IAE 0.3. ISE is 0.09. We have to see the response. Yes, we got. What is the set point? Set point is 1. Where it is settled? Settled at the points between 0.6 and 0.8. Are you able to follow? It is settled between 0.6 and 0.8. What is the set point? 1. What is the controller we are using? P only controller. If you use PI controller, then only the steady state error will be removed of controller. Now we will do the PI controller and see the response. Here PI controller means 0.9 times. Am I correct or not? multiplied by 0.9. What is I mode?